Hello folks, well there's no prizes for guessing what I'm doing today. It's one of my own sets, and I know we've got a G-Cole GT858 to have another look at. I've not launched the first part of that video, extensive receive fault. I don't think it's worked from new. Lots of those immaculate sets for sale haven't worked from new. So H469 is the Harvard SOS, and it's the worst of the emergency kits, but they are all to love. And this one has come with the instruction card, which you don't normally find. And it's come with the instruction book, which you don't normally find. It's come with everything, hasn't it, this one? It's like chocolate box plastic. Now, here's the killer on these. It's the magmount. So these can be used as a walkie-talkie. You can put AA batteries in there, especially if it's got a new battery thing, which that looks a bit sad. I think they've broken the clips off that as well. So it's 3-channel crystal controlled. So you've got 9, 14 and 30. So in reality, although calling channel's supposed to be 40, in reality the centre of activity is 19. It's got high-low power, and it uses a 3.5mm jack socket rather than the phono. So I don't know whether that's better or worse. You can put this telescopic aerial in the top and use it as a walkie-talkie. I don't know whether we've done a field test with one of these, probably have. But the letdown's the mag mount. So unless we've previously always had dodgy mag mounts, it's the strength of this mag mount. And if we just take a lid, here's one I prepared earlier, and stick that on, actually that might be better. But I've never been able to move a car with the magnetic aerial on. It's quite a long magnetic aerial as well, so theoretically it could possibly work better than others. You know what? You know, at the end of the day, it's supposed to have broken down. I don't know. I'll see what Mr. Chippy thinks. Got a little kink in it. I'll just try and unkink that. But at least it's in one piece. Right, so we've not had one that strong before, I'm sure. And so your antenna connector is a 3.5mm jack on this one. But we happen to have got a 3.5mm jack to SOS239 because those Harvard handhelds use them as well. And these are cleared out of the same factory. They're not rugged. If you dropped it, that would be it. And here's the other thing, of course, with it being crystal controlled, what's the chances of the crystals still being anywhere near, because they're not going to be individually adjustable. So I went to the trouble of printing out the instruction book to show you, because I previously scanned that, and of course we already had that information because we've got the instruction book. I told a radio amateur yesterday I was going for a 10100. He said, I don't know anything about those codes. You know, I've been licensed since 1979. I think that's a I know nothing about CB radio statement, don't you? Do you think that was a bit of pseudo snootiness? I'm not a CB, I'm a two-way radio service engineer. But do know some of the codes, and some of those things like square wheeled and you're pushing me into the strawberry patch they're just wonderful phrases. So allegedly it does 4 watts. I'd like to see that. 0.7 microvolts for 10 dB, quite possibly. These are obviously going to be bleed over box. We've got the circuit diagram. I think it's a single conversion receiver, isn't it? Anyway, let's find out. So you don't often see them as complete as this, or not smashed up. HK for Hong Kong, I expect 77632144. These were $69.99. But of course you could use it as a cumbersome walkie-talkie, because the telescopic arrow sticks out a foot in its lowest position, doesn't go all the way in. And I've also noticed these are pretty, I'll just take somebody's previous owner's address off. These are pretty crummy. Push to talk bars there, and you've got a TX light there. Now we can't do much with testing this cyanide without opening it up. Did I tell you I've got 20 minutes? So we'll connect it to the test gear, we'll make a start on filling our sheet in. If it works, I'll be back to that instruction book to see how many volts these are. There's some emergency sets you can use with the engine on, and some you can't. So that's antenna. I'll go and borrow one of Mr. Chippy's leads, because I don't want to use a cigarette lighter lead because we don't have cigarette lighter facilities on this bench. Just going back into the instructions, the specification for the voltage. Yeah, it says 12 volts, doesn't it? What's it say on the circuit diagram? It's MPSU 31, which is a 12 volt device, so we're not going to put more than, we're going to absolutely thrash it at 12.8. Don't go higher than that. I think 13.8 would kill the PA transistor. Right, I'm just going to go and borrow one of Mr. Chippy's leads. Right, we'll get that connected to our power supply. These are the ones which Mr. Chippy makes and we do have available on eBay. These are not 2.1, I think they're 1.9. Quite something different to get hold of. 2.1s are a bit floppy. Not going to be a good contact. Right, let's switch on. So we'll go with 12.8 volts. This isn't a good start. I'm sure it's centre positive. Right, well that didn't work out. I'm just going to have to use the cigarette lighter lead just as a check. It could be 1.7mm on these. The reason I'm reluctant to use these is this cable's only rated for about 3/4 of an amp. So you're doing current limiting. That's how it ends up. We've got no power with the correct lead either. So I think we're going to have to open it up and see why we've got no power. It looks like we've got a fault. So put that to one side. Of course it needs replaced. They're readily available. We've got them in stock. Don't want to lose that. I think that's the only screw. And then it's clips, which you hope aren't going to break off. There we go. So I'm now tempted to connect my crocodile clips to here. No, still got nothing. Well, this is going to be fun. I thought we'll get on with this because I've got 20 minutes. I can get well into this in 20 minutes. Right. Don't ever blow the output transistors there. Even when they were new, they were about £15. Now they're even more difficult to get. I did get some from the United States, but I had to pay for the privilege. That's the screwdriver. We're going to have to take this out of its case. I wonder if the on and off switch has failed. So we'll take the board out. Do you all get, when you look on eBay and you see stuff which says rare in the title, why would anybody put the word rare in the title? Because the title is what people are searching for, and nobody's searching for rare within CB radio. They're looking for a specific model. So, you know, you'd put Harvard H469 SOS or whatever this is, if this is what you're looking for. Not rare. It's a waste of words. Might work on a market stall along with look using the @ symbol. So I shouldn't have taken that one out, so its nuts fallen off. So we'll deal with that immediately. Right, well, put that back together. So back to the question in hand, why haven't we got power? So we're going to keep the negative on the negative terminal. We're going to now look at, is that the input, is that the output? Right, so what we've found is I've now got power by cleaning the switch contact. So what we'll now do is we'll go back to running it from the power lead Mr. Chippy's mates. Kind of put that back in its box. Because I'm hoping we won't have to go in there again. I'm going to put the screws back in that hope. No, I'm not, because you know what? To do the cyanide, I'm going to have to put the thing on the speaker, aren't I? So it's going to have to stay in bits. Right, let's just go put Mr. Chippy's. We'll get rid of the factory power lead, which isn't really thick enough for testing with. The ones Mr. Chippy does are capable of 3 amps. Alright, we've still no power on the external power lead, so it may be the wrong size plug. We're back to that again. Alright, we'll run it from here. I'm going to run out of time. Right, and now we want to plug in to extension aerial. Right. Switch picture in picture on, and are we going to get something when I press transmit? I'm on the 3 watt scale. Where is transmit? On the front. The trouble is the board's not in, so I'll tell you what, we're going to have to take the board out. Just to hit the press to talk switch. Whoa, well, it certainly does the power. I was expecting some epoxy 2.3 watts or something. 3.6. Of course, what channel am I on? So we've got 9, 14, 30. So we're going for the centre one. It's 3.5 watts. What's the frequency? Let's go over to the frequency counter. Twenty-seven 73131. I think we've got to optimise this on channel 30, which sounds bonkers, but it's the only spare channel, isn't it? Because 9 is supposed to be emergency channel, 14 is supposed to be calling channel, 30 is a free channel. So when we do an on-the-air test with this, which we can do because we can connect external aerial, it's going to be on channel 30, so we're going to need to optimise it on channel 30. So let's just see what position 30 is. It's the lower position. I'll just see if it works on 9 out of interest. It does, it's 68141, so it's within. Let's go to there. 89095, it's within. And it might be adjustable on the frequency, but only one channel. So we're gonna have to select the one we want to do. So you know what? Let's look into, instead of fiddling about with the receiver now, let's just see whether we can do this. But trying to find the component numbers without a layout is going to be fun. So, in the output we've got variable capacitor 1, that's our final bit. You know what? There's me calling these sets names, and these channels are individually frequency adjustable. Now, how's that for a cheap set? Wow. And they're slug tuned, which is better than using little variable capacitors. I've got no idea what the channels are. I'm going to need a frequency chart, but we're going to have that in a service manual for another set. What's this? I don't think we're going to find it in the HCB one. I can remember channel 1 and 40 and 20 and that's it. I have a memory like a sieve. What's this manual? Fidelity base station. Oh look, frequency chart. That's what we want. So we are on channel 30, and if I can find the push to talk button. $89096, this channel 30 yet. So 89125 we should have, and I expect they're in order. Not that one. Looks like they're in reverse order. That's as high as we're going. Channel 9. No, it's 14 next, isn't it? 73125. Channel 9, 68125. Is it that one? Yeah. Well, why wasn't that working the other way around? Right, back to the centre channel. Well, how's this? Don't tell me this is the centre channel, is this crystal? It is, isn't it? Right, and so channel 9 must be the centre one. Just no, 68125. They're interactive, aren't they, to some extent? What a nightmare. Channel 14 is the outer channel, and so channel 30 is the centre channel. Right, channel 9, interactive, you see, so that it's changed. .68125. I mean, they're all near enough. I'm being silly here. Channel 14, 73, 125 is this one. And channel 30 is the centre one, 89125. There we go. Right. So it's on frequency. So we're trying to find transformer 4, 3, 2 and 1 to peak this. But of course we can't determine what's what. It's so close. What I'm going to do, I would think we're going to be looking at those two are the earlier stages. I'm not going to touch them because he's doing 3.5 watts. So what we will do is touch that one. We're now looking at power. That is spot on. Then we'll do the variable capacitor. Whoa, some squedging there, isn't there? And that is going to be the loading coil adjustment for the if you're using it on its telescopic aerial. I'm not going to do that because it looks like it's a new set. It's not been messed with. So how do we access low power? Well, let's see what we've got. It's 3.8. Am I on channel 30? Yeah. Out of interest, what's it doing on the other channels? 3.8 on channel 14 and on channel 9 it's doing 3.95, and it's hot, so it's going to go up a bit when it's cooled down. So what's the current consumption? 780 milliamps. And somehow we can get to low power. And let's look at what that is. It's 410 milliwatts. It could be adjustable if we can find variable resistor 1. Now on the circuit I can find 3 variable resistors. It's going to be that one. We've got squelch. We've got squelch, power and deviation. So surely this is going to be low power. It is. Now we didn't need to do that because it was at 410. It's now 400, but I've proved that it is the case. So 400. I think we'll take a photo of this. I do have another one, and by taking a photo of this, it will make the one quicker to service. So it doesn't have a meter, of course. We do tight squelch, so we're on channel 30, which is what we're working on. So 2789125 on the signal generator. 2989125. Twenty-seven 89125. Right. Well, that's 1 microvolt. It's probably about your lot. Let's get the test set connected to the loudspeaker. Do we need an earth on this? That would be disappointing. Looks like we do. No, we don't. I was expecting the white wire to be hot, and it isn't. It's the other way. Okay. So let's see if we give you a cyanide reading. Once again, I'll check if we need an earth. No. I can't get one because it's so distorted. Right, let's look at the oscilloscope. See whether we can do something with the detector, and I have Well, we'll come back to that. So a few hours later, I'm so unhappy with the waveforms we're getting on the receive that I'm going to change 3 capacitors in the audio section. These are very difficult to work on, double-sided cheap boards. I can't think I've ever changed a part on one of these before. So we're going to give it a go. So when I look at the circuit diagram, which I've printed off a portion of to the wrong printer, right, a bit of exercise later. I just kind of did a enlargement from the circuit scanned onto my computer. So we've got the LM386 audio amplifier here. You've got 100 microfarads there, which couples the speaker, and then you've got 10 microfarads and 10 microfarads. There are no other capacitors which could go wrong in the audio stage. So although there are other capacitors, this isn't a high hours thing, of course it isn't. But they could have failed simply due to age and being cheap and nasty. We have that with the Unidens, don't we? Because those capacitors they chose to use didn't work out to last that well, and it's the same with some of the Sony camcorders in the 1990s. Despite costing £1,200, they ended up with Sanyo capacitors that didn't work as well as was ideal, and so did Canon, and so did Sanyo themselves. So we don't know what the layout is because we've got no numbers, but hey look, there's the LM386. I expect that's 100 microfarads. If it is, we change it, and then we find a couple of 10s, and hey presto, it either works or it doesn't. Right, so I've changed 4 capacitors, simply because there were 3 which were 10 microfarads. So without spending ages looking at how the circuit is, I've changed 1, 2, 3, and then we've changed, what did I say, 1, 2, 3, and then the 100 microfarad there. I think we have got a bit of a difference, but not a dramatic. So I need to set my secondary signal generator for 455 kilohertz because that's the only IF. So we've got these somewhere in the memory. Which is there. We'll turn the tone off. That's pretty off frequency. Not stupidly off frequency, but I'll tell you what, we'll go to the frequency counter and nullify it with the signal generator to see where we actually are. I would think it's going to be low. So instead of 89125, it's 064. Well, it's such a wide receiver. I can't think it matters that much, but I'll tell you what, we'll tune it up. I would suspect that this trimmer here changes the frequency. I'll just see whether we can. I'll just see. I'm going to go back to normal signal generator. We'll just take that away for a moment, just in case that helps. I'm going to look at the cyanide meter because it might help the activity. Yeah. Just check that one as well. Again, I'll check that it isn't frequency. So that actually has brought an improvement. Come back with the signal generator. Make sure this doesn't affect frequency. No. So it's slightly low, but it's a single conversion receiver as wide as a barn door, so it's not going to matter. At least it's working, and we have improved it. That coil is where on the circuit. It's going to be T8. Right. Let's just have a look once again, just see if there's anything more we can do with this lousy waveform. I think we're going to do it for best synad. It's not the right way to do it, but that is as good as we're going to get. And we actually have, for 12 dB synad, we've actually got 2.4 microvolts. I can't do it, it wouldn't read before, if you remember. (10 dB), 1.8. It's not going to do 20 in a month of Sundays. No. So we've brought it from no synad possible to that. Now we're going to do something here, and that is we're going to go to a different mode. We normally use EMF in electromotive force, which is harder to achieve. These manufacturers are mainly going to use PD mode to make their things look better than they are. Now let's have a look at these again. So in PD mode, we're only a whisker away from 1 microvolt, 0.84 microvolts for 10 dB synad. And remember, they're quoting in their thing that it was something like 0.7, didn't they, for 10 dB synad. 0.7, we've got 0.82. So it's not far out from what they say when put into PD mode, which is what they'll be using. Actually, this seems to transmit better than it receives. I've never had any luck with these on receive. I think they're real cheap and nasty, aren't they? You know, but I'm so surprised that we were able to adjust individually the transmit frequencies, which so many of these cheap type of things don't. So perhaps with it being higher power at 4 watts, or a whisk away from 4 watts, they do let you do that. So I'm going to look at deviation. We've done everything we can do on receive. There's a preset squelch, so we'll do that. We did low power was there. I'm guessing that's deviation, and I'm guessing that's going to be squelch. So let's put squelch to full, not volume to full, squelch to full. Let's go over to this so you can see what I'm doing. I'm going to see if we've field tested one of these before as a walkie-talkie, because I'm minded to do that, because it probably works better than you think. He says. Right, squelch. Full squelch is 30 microvolts. I like it to be 100 microvolts. Can we adjust it? Am I going up or down? I don't think that's squelch, do you? No, Mr. Tango. Let's try this one. That's squelch. So that was me shown, wasn't it? And that's my 100 microvolt squelch, which is what I was hoping for. So I've got that. So it was 30 before. I should have see what the sensitivity was. I didn't. Let's see what it is now anyway. Doesn't sound like an FM receiver, you know this. It's a bit like the Fidelity 1000, it doesn't use any clever FM chip. Minimum it's going to do is 3 microvolts. But we can turn the squelch down. I mean, if you can hear that, I'll turn the tone off, on, that's 0.3 of a microvolt. I only stop hearing it at 0.18. But it's like at the back of the box, like AM would be. So there we go. It's not going overloading on a full signal, so we are as set as we're going to be. I've just got deviation 2, just want to quickly recheck transmit. Of course I'm on low power just when I want to recheck transmit. That's channel, that's power. It's actually 4 watt, it's a full 4 watt output when cold. So when Mr. Chippy does his scratchy corner test, we'll be saying it's a full 4 watt output because it jolly well is. So what I've put down at 3.8 is when it's warm. We often do that. Make it as bad as we can. Right, I'm going to go to the deviation meter. I'll tell you what, we'll use this deviation meter first. I'll have to retune this. I'm going to go to low power once again so without heating up the transmitter. And so I don't get my fingers RF burnt, reaching under the board is probably more to the point. Right, wallow, wallow, wallow. We're getting... Of course I've altered the deviation, haven't I? Because it turned out to be that preset. I tell you what, I can disconnect my test gear from receive. Wallow. That's about 2 kilohertz on this test set. And I'm not showing you the meter. Do that again. Wallow. It's beyond. It's over the top now. Wallow. That's about where it looks to be right on this test set. I'm going to go over to the test set behind me for accuracy. I mean, interesting on the air test if channel 30 is occupied, isn't it? And this is going to pick anything up that's anywhere near. Right, I've somehow got to do my thing into this whilst looking at the meter behind me. You know what? I wonder if we can run it on the cigarette lighter lead it came with. It doesn't work on Mr. Chippy's lead, but I think it's because it's 1.7mm. It would give me a bit more wire. Yeah, it works on that. Wow, it's spot on. Well, I'm glad about that. It's absolutely hitting the 2.5 with an absolute peak. So, wow. Looks like the Marconi was working today on deviation. Right. Right, well that's it then folks, we will put it together. At least it has a electret mic and not relying on using the speaker twice like some cheaper things do. This seems to be shifted over to one side for some reason, I can't see why. Wow, that took some doing. They don't mean that to fall off. There's the one and only screw. I thought they were a bit miserable with only putting one screw in it, but then we had all that difficulty putting it together. So we've got the battery pack which is rusted, but they're readily available. We've got a battery door with its broken clips, not readily available, so it's going to have tape on it, isn't it? I expect they're all the same. So there we go, the ugliest one you've ever seen. Let's power it up. Into our test set, making sure we're still okay. Yep. Right, we'll swap this for the aerial. I'll tell you what, we'll put the squelch on as well. This LED says battery low, so if I apply 9 volts, it probably comes up lit up. Well, it hasn't. But you know what? We're going to press transmit. It might only do it when you're in transmit. We're not going to be able to go 1.9 for a Roger, are we? Just going to press transmit. Let's see whether this lights up. No. Oh, let's go to 12.8 volts. Well, I'm not going to play with the power supply. I've got better things to do. Let's turn the squelch down. So we're on channel 30. That's channel 14. And that's channel 9. And I'll tell you what we're going to do as a final thing. Put my walkie-talkie on. Pop it down to channel 9. We're on low power.
Testing 1, 2.
Over to channel 14.
Testing 1, 2.
And channel 30 we've worked on.
Testing 1, 2.
There we are. So there you are. You've seen. We'll turn the squelch down again. 30, 14, 9, 14, 30. Thanks for watching the Harvard H. I've forgotten the number already. 469. 3-channel emergency radio from 1981.